Hello. We're going to be looking today at how to graph a linear inequality on a two-dimensional plane. So first of all, we better remember how to graph a linear function first. Hopefully that's not something that you've forgotten while we've been gone. Let me zoom out a little. Let's say that y is equal to a 3x plus 2. Okay? When we've got an equation like this, remember it's in that y equals mx plus b form. So in this one, my m is 3 and my b is 2. So we have to remember, what does the b represent? That's right, it's the y-intercept. And then m represents our what? Our slope, right? And remember that slope is rise over run. So even though it's a whole number, it's nice to think about it in terms of a fraction, right? So if I want to graph this, I'm going to get my graph on here. Okay, so if I want to graph this linear function, I'm going to use my y-intercept is 2, so I go up to 2. Right? And then my slope is 3. So this is my rise, and then this is my run. So I go up 3 and over 1. Over 1 and then up 3. This is kind of a small graph, so I'm actually going to go down 1, 2, 3, and then over 1. Down 1, 2, 3, and over 1. Right? I can go back as well as I can go to the right. And I want to have as many points as I can so that when I connect my lines, my line is right where it should be. Okay? So hopefully this is something that you remember how to do. If you're given an equation, you should be able to graph that equation. What we're going to look at today is, can we graph these equations, but they're not just equations, they're inequalities, which makes it really, it seems like it's going to be really different because it's going to look different, but the process is still the same. So let's say that we've got y is greater than 3x plus 2. I'm going to be looking at the same one that I just looked at. Okay? And junk. There we go. So y is greater than 3x plus 2. So that means I'm going to go up 2. And then I'm still going to follow my slope, right? And just still following my slope. The only difference here is I have to look and decide, does this mean that it's greater than or equal to? Right? It's not equal to, right? It doesn't have that extra piece, so that means that I'm going to have a dotted line. Okay, my line has to be dotted because in this case, it's not an equation, right? It doesn't equal that line. If this was a y is greater than or equal to it, then it would equal it. But in this case, it doesn't, so I'm just going to have my dotted line. Now, if we think back to solving those inequalities and getting our answers for x, we graphed those on a number line and we ended up shading part of it one way or the other, right? The same thing is going to happen here. The idea is this is a boundary line. Okay, this boundary line is the cutoff point between the side that makes it true and the side that doesn't. So what I want to do is I just want to pick a point and plug it in. I am always going to pick 0, 0. You want to pick a point not on the line. If it's on the line, then it won't tell you which side of the line to shade. But I'm going to pick 0, 0 because that way I can tell really quickly if it's going to work or not. It's easy to plug in. I don't have to think about which is my x and which is my y. If my line goes through 0, 0, then I pick something like 1, 1 or 2, 2, or just something that's going to be kind of easy for me to plug in. So I've got is 0 greater than 3 times 0 plus 2. So is 0 greater than 2? And that's a big fat nope. So that means that this side doesn't work. This side over here is the side that makes it true. Okay? So it's not true, so we shade the other side. If it were true, then I would shade the side that it was on. What this means is that if I were to pick any point on this side, it will make this inequality true. Let's pick a point just to test it. So let's pick a point of -2, 0. Okay, let's see if that works. So the point -2, 0. So is 0 greater than 3 times -2 plus 2? So is 0 greater than -6 plus 2? Yeah, 0 is absolutely greater than -4. It works, right? So that means every point on this side of my line is true. Let's look at another one. I'm my pre-made graphy things that I did before. So let's look at, let's look at something where we have to get it into slope-intercept form. I'm sure you're going to like that a lot. Let's say I've got a 2x plus 3y is equal to 6. Okay? So the first thing I've got to do is get my y by itself. So 3y is equal to -2x plus 6. Then I have to divide everything by 3, right? In order for it to be slope-intercept form, my y has to be isolated. So y is equal to -2/3 x plus 2. So I've got my y-intercept is 2, and then I'm going to go down and then over. Down 2 over 3, right? Or I could go back 3 and up 2, back 3 and up 2. Now for this one, I messed up. I should have had it be an inequality. Oops. So we're going to go less than or equal to. Okay? So in this case, it's less than or equal to, which means that I'm going to have a solid line. Right? If it's greater than or equal to or less than or equal to, if it has that extra piece, then you have a filled in line. It's just that same idea as that filled in circle. So I'm going to fill in my line, a nice solid line, and now I pick a point. I'm going to pick 0, 0 and see if it works. I like to always plug it into my original. That kind of makes it a little bit easier. Is 0 plus 0 less than or equal to 6? Yep, so I shade that side. It's true, so I shade the side that includes 0, 0, so I'm going to shade this side of my graph. Okay? How are we doing? Doing all right? You might end up with something that maybe isn't linear. They've given you some where you've got a couple of exponentials that you might need to graph. So let's say I've got that y is less than 2 to the x plus 1. What's going to be the best way for me to graph this? What do you think? I think I should probably just plug in some points, right? Initially, just like when I did these lines, I just treated it like it was a linear function and I just graphed my boundary. I just almost pretended that it was an equal sign. So I'm going to go ahead and I'm just going to make myself a table. X, Y, -2, -1, 0, 1, 2. Right, and I'm just going to plug in some points and see what happens. So I've got 2 to the -2 power, not 1/2. -2 minus 1, plus 1. A negative exponent, that's going to flip it down below. So I've got 1 over 2 squared plus 1. So that's 1/4 plus 1, which is 1 1/4 or 5/4, however. I'm going to go with 1 1/4 just because I'm doing it on a graph. And that's where mixed numbers are a little bit more helpful in terms of counting, right? For -1, I'm going to have 2 to the -1 plus 1, so 1/2 plus 1. Well, that's easy. That's going to just be a 1 1/2. 2 to the 0 power plus 1. Well, that's going to be 1 plus 1, which is 2. 2 to the 1 power plus 1. Well, I can plug in a 1, right? So 2 to the 1 is just 2 plus 1 gives me 3. And then 2 squared plus 1, well, that's 4 plus 1. That gives me 5, right? So I can just make my table real quick. Doesn't have to be anything fancy. So I'm just going to plug these in now. So I've got at -2, I'm up here at 1 1/4. At -1, I'm here at 1 1/2. Then I'm here at 2, and then 3, and then 5, right? Oops, sorry, you couldn't see that very well. So this one is going to keep going and get closer and closer to that. And then it's going to curve up and get really steep like that, right? We've looked at these exponentials. That's what all the entire last chapter was about, was getting graphs of those exponentials. So now that I've got this, I'm going to plug in a point. I'm going to plug in 0, 0, see what happens. If it makes it true, I shade this side. If it doesn't, then I shade this side. Even though, ooh, what did I do wrong? What's wrong with my graph? So this is why I really wish you guys were in class, because somebody would have said, hey, Miss Machado, you just screwed it up. And then I would have been able to fix it. Look at my sign. Is that a less than or equal? Or is it just a strictly less than? So what should this look like? Because it should not be this nice solid line. It should be a dotted line, right? So I should go dot, dot, dot. It's a dashed line all the way up, right? Now let's say it's a test or something and you make a mistake like that. You could even just go and write the word dotted there and be like, hey, Miss Machado, look, it's supposed to be dotted. I swear it's dotted, but you drew it a little dark and it doesn't erase very well. That's fine. You just want to make sure that I understand that you know it's supposed to be a dotted line. So if I plug in 0, 0, I've got 0 is less than 2 to the 0 plus 1. So is 0 less than 1 plus 1? And yes, it is. Right? And so if I shade this side, notice I'm shading the entire extra piece. I just have everything but that one little corner that's been taken out there. Okay? So this one is pretty straightforward. If you look here, you've got 15 problems. Most of them are linear. In fact, the first 10 are linear. You only have 5 that are exponential. And so those ones you'll definitely want to make a table, make sure that your graph looks good. Make sure to pay attention. This one here would be a solid line because it's a less than or equal to. This one would be solid, right? This one would be in a dotted line because it's that just greater than or just less than. If it doesn't have the extra piece, remember you don't fill in the line. Make sure it says on a separate set of axes. Do not try and graph all these on one. I've seen a lot of you guys where you try to graph all of your lines on one graph, and that does not work. You can't see the features of the individual graphs, and especially with things like this where you're shading. Once again, you've got the answers for these. I did not do an answer key for this one because the answers are right here. Their worked out answers are the exact same as what I would give you. The only difference is you might see me, get a variable by itself, but that's not something that I expect you to struggle with. Okay? So take your time, check your answers, and remember, reach out if you need anything. Have a wonderful day. Adios.